All right, so we're number 5. All right, so what does that mean? Right. So M and N are inverses of one another. And it tells us that M of 5 is equal to N to negative 9. So what else do you know? Right. So if M has a point at 5, negative 9, you know that N has a point at negative 9, positive 5. Right. So then they give you that M prime of 5 is equal to negative 8 over 11. So then what is N prime of negative 9? Right, good. So N prime of negative 9 is the same thing as the reciprocal of M prime of 5, which you know to be negative 8 over 11. So the reciprocal of that is just negative 11 over 8. Yes. Probably not. Like we need to finish this chapter so we can move on to chapter 4. So probably not going to quiz. So. Yeah. Just all chapter 3. About a week behind where I was last year. But we also started later this year too, so it evens out. No. All right, number 6. Selected values of a one-to-one differentiable function, f and g, and f prime are given in the table above. If f of g of x is equal to x, which is equal to g of f of x, find g prime of negative 3. All right, so this is saying that f and g are inverses to each other, right? Inverses. Okay, so it's asking you where find the slope of g at negative 3. So we need to kind of come up with like the reciprocal, not the reciprocal, the corresponding point that goes with this. All right, so we need to figure out where does f of x equal negative 3. All right, so using that chart, where do you get that? That's 7, right? X equals 7. All right, so we know now that f has a point at 7, negative 3, and then g has a point at negative 3, 7, right? So then the slope at g prime of negative 3 is going to be the same thing as 1 over what? How are we going to come up with the slope? F prime of 7, right? And what is f prime of 7? So the slope for g at negative 3 is just a half, right? So again, corresponding points have reciprocal slopes. So if the slope here is 2 at its corresponding point, the slope is just the reciprocal. So do you get how we use these two? Yeah. Right? So the corresponding like x value that goes with, since f and g are inverses, the corresponding point that goes with -3 is +7, right? Right. Right. So if I know that the slope of f prime of 7 is 2, the slope is just going to be the reciprocal of that. I don't know, x is 7. So they gave us that for g, they gave you -3, right? So you have to say, all right, where does f of x equal -3? So they're inverses. So the range of f of x becomes the domain for g. So this -3 is technically a y value for f of x, and then they just switch for the g function. So where does f of x equal -3? It's at 7, right? So you know that f of x has a point at 7, -3, and then g is just the opposite of that. All right? Okay, so last part is talking about inverse trig functions. Did you guys do inverse trig at all this year? A little bit? Okay. All right, so inverse trig is just it's the opposite of what trig is. So when you take like sine of, say, pi over 4, you get radical 2 over 2, right? So you're taking the sine of an angle and you're getting a ratio based off of what it is on the unit circle. Inverse trig is just the opposite of that. So if you're taking the sine of an angle and you're getting a ratio, when you do inverse trig, you're taking a ratio and trying to come up with the angle. So if I were to do, say, arc sine of radical 2 over 2, so you have to ask yourself, all right, where on the unit circle does sine equal radical 2 over 2? And that would be pi over 4. Right? So they're just kind of opposites to one another. All right, so when you do, like for arc sine, because we have to kind of restrict the domain and range. All right, so the domain goes from -1 to 1, right? Because that's all the values that you're going to get for sine, right? All your values are somewhere between -1 and 1, and then your range is going to be somewhere between -pi over 2 and pi over 2. So if you imagine like drawing yourself the unit circle like that, the only values that we're really concerned with are the ones that are like right here. Because if we use the other values, like you no longer have a function. So you only want to use like a specific part. So again, we're only going from, again, let's say this is the unit circle, right? You have 0, pi over 2, pi, 3 pi over 2, 2 pi. We're only interested in from here to here. So this would be -pi over 2, 0, pi over 2. So we're only, just for sine, yeah. So you really only have to, again, you really only need to remember the first quadrant, and then, again, it's just a reflection over to get the fourth quadrant. Okay. 0. Yeah, we're using just 0. Right. Yeah. Cosine's kind of the same thing. Tangent you can plug in really whatever you want, and then your range will just be from negative pi over 2 to pi over 2. Most of the questions that I've seen will ask you, more like arcsine or arccosine, because those are more of the easier ones to remember. Right. So again, it's just like usually when you take the trig function of an angle, you get a ratio. Now you're just taking the ratio and trying to come up where on that unit circle does it happen. All right, so arcsine is the same thing as sine to the negative 1 of x. You guys will see both kind of notations. So this really means the same thing as that. All right, if you have, say, the inverse of cosecant is the same thing as 1 over sine to the negative 1, which is the same thing as 1 over arcsine. All right, so if you were to say I were to ask you, like, what's the arcsine of 1/2? Right, so like where does sine equal 1/2 on the unit circle? What did you say, Kel? All right, what's the usual ratio for sine if you're talking about a triangle? Right, opposite over what? Right, and what else? It's usually if you're talking about like an ordered pair, sine is usually the what? The y value, right? Over r, right? So if it's telling you that arcsine is 1/2, that means that if you have an angle here, your y value would be 1, and your radius would be 2, right? Opposite over hypotenuse. So where on the unit circle does arcsine equal 1/2, or where is your y value 1/2? 5 or 6, right? Right. So that's how you would get. Okay. So again, think of the unit circle. And again, we're only interested in like right here. So where does sine equal 1/2? So where's the y value equal to 1/2? So it's positive, that means it's up here, and it's the short one, right? So this is pi over 6, pi over 4, pi over 3. So if it's the short y, that means it's over here. If it was the long y, it would be up here, and that's pi over 3. All right, so it says if y equals arcsine of x, find dy over dx. Okay, so we don't really know what the derivative for arcsine is yet. What do we know the derivative of? sine, right? So I need to somehow get rid of that arc sine there. All right, so how can I get the arc sine to go away? No. So like if you have x squared, right, and you're trying to get it to if you have x squared, right, and you're trying to just get x, right, what would you do on both sides? Take the square root. So you take the inverse, right? So what is the inverse of arc sine? Sine, right? So you're going to take sine on both sides. So sine of y is equal to the sine of arc sine of x. Okay, and what that does is that what you do to one side, you got to do to the other. We're trying to get the arc sine to go away, right? So when I take the sine of arc sine, what that does is it cancels it out, and all you're left with is what you're taking the ratio of, right? So the sine cancels out the arc sine, and you're just left with x. Right, so sine cancels out the arc sine again because they're inverses, and all you're left with is just x now, right? So you have like x squared. What cancels out in x squared so that you get x? Or square root, right? They're just inverses of each other. So arc sine and sine are inverses of each other. Cosine and arc cosine are inverses of each other. Yeah. Like the x is like built into the yeah, but then you'd be left with x over sine. You don't want that. We're just trying to get, like right now, we're just trying to get the x to be by itself. Because we don't know yet what the derivative of arc sine is. So we're trying to get it into things that we know, which we know. We know how to do this, we know how to do that. Right? So I see your thinking process, but it's not going to help you. It's going to be like more challenging. All right, now, so we're going to take the derivative on both sides. So what do you get on the left side? Cosine of y dy over dx is equal to 1, right? So then dy over dx is equal to 1 over cosine of y, which is equal to what? Secant of y. Okay, now, so we're almost done, but this says the derivative of y with respect to x, but what is our equation in? It's in terms of y, right? So we need to kind of back up a little bit. In terms of x, though. The derivative of y in terms of x. This is in terms of y. If it has an x variable, then we'd be good, but we have a y variable. All right, so we need to kind of have arc sine of x. All right, so again, this part here is your ratio. All right, so what's another way that I can write x as a ratio? X over, right. All right, and then what do you get out from when you evaluate an arc sine function? If you're taking the arcsine of a ratio, you get a what back? An inverse, but usually when you take the evaluated trig function, you're evaluating at an angle and you get a ratio. But when you evaluate an arcsine at a ratio, you get an angle, right? So this is the angle, okay? A little bit. So if you draw yourself all right, so it tells me that sine is x over 1, and then the sine ratio is what? Y over r. Right, so the y value, imagine this is again on a xy grid, so the y value would be here, and then the radius would be here. Right, so this is telling me that this is that's your y, and that's your radius. So you have x, and you have 1. Now, how would I get this missing side here? Right, so what would you get? So you have, say, like x squared plus the missing term is equal to 1 squared. We'll call this like side squared. All right. B, you want to go B? All right. All right. So if again, I want to solve. This side here is what I want to solve for. So I want to solve for B. So I have B squared equals 1 squared minus x squared, and then B is going to be the square root of 1 minus x squared, right? So this here, well, 1 squared is just 1, so. No. So this side here is 1 minus x squared, right? So we're given secant of y, so what is the secant ratio? So what's the secant the inverse to? Cosine, right? And you know cosine is the x over r. So secant must be r over x, right? So what would that be? What would the secant ratio be? Right, so what is like the secant here of theta? Good. All right, now this part here, that is in terms of what? X now, right? So, right, your secant of y turns into 1 over 1 minus x squared. So that right there is your derivative for arcsine. This is more like a visual, not a visual, but like a proof on how we come up with the inverse trig derivatives. Right. You can do the other ones for the other trig functions, but they're a little bit more difficult. But just want to show you that so that it's not like we're just pulling stuff out of a hat. Like there's a reason why it is that. Right. So you have your derivatives for all 6 of your inverse trig functions. Now I'm going to tell you that these 3 are the ones that show up the most. The other ones don't really show up that much, but again, it is still good to know them. So it's arcsine comes to be 1 over the square root of 1 minus x squared. Arctan shows up a lot, which is 1 over 1 plus x squared. And then arcsecant, 1 over the absolute value times x squared minus 1. And again, any derivative of any co-function is just negative. So Sine and cosine go together. They're the same thing. The only thing that is different, cosine is negative. Tan and cotangent are the same thing. Cotangent is just negative. Secant and cosecant. Now, the only difference is if you have a, say, like a chain rule. So say if we were doing like arc sine, say, of 2x. Right? This is like your blob here. Right? So this here is going to replace like the x term. Right? Wherever you see an x. Right? So if we were to take the derivative of arc sine of 2x, right, I'd have 1 over the square root of 1 minus 2x squared, and then multiply by the chain rule, which you get 2. So your final answer would be 2 over 1 minus 4x squared. All right, so that's really the only difference. If you have, you know, what? This here comes from the derivative of 2x. All right, so anytime you have something that's not just plain x, you have to replace whatever you're taking, whatever your ratio is. You put that in for the x term there, there, and there. Yeah. A lab period? Look into it. I don't know how that's 3, 5, and 7. Yeah, but I don't want you guys missing other classes. Just yeah, but like. I know, but it's just like, I don't know when it's gonna, you know, there's not like a convenient time for everyone that it would work. The only other way that we could do it is like after school. But I know you guys are busy with sports and stuff after school, so I'll look into it. I know my cousin teaches at Rutgers Prep, and they have like, say you have like 6 classes, and you drop one like every day. So like, say you know you have periods 1 through 6. On Monday you would meet periods 1, 2, 3, 4, and 5. You would not see period 6, and then the next day you would say drop period 1, and you would only see 2, 3, 4, 5, 6. And then there's like one day you meet like double period or something like that. I mean, they're a pretty prestigious school, so yeah. All right, let's see if we can get number 8 done before the period. All right, find the equation of the tangent line to the graph of inverse of cotangent at x equals 1. All right, so you need a point and a slope. Now, the point, right, so you're taking the x value would be 1, and then the y value is going to be cotangent to the negative 1 of 1. All right, so you have to think like, all right, where does cotangent give me positive 1? Where does tangent give you positive 1? 45, right, which is the same thing as? Right, you get radical 2 over 2 over radical 2 over 2, which comes out to be 1, but what's the angle there? Right. Cotangent is just the same thing as that. All right, so the y value would be pi over 4. Now the slope, we just get from the derivative, right? So the derivative of cotangent is dy over dt. Well, you know tangent, and cotangent is just negative. No. All right, so your derivative comes out to be negative 1 over 1 plus x squared. And then what is the derivative at 1 and pi over 4? Okay, so your tangent line is what? Y equals what? Pi over 4 minus 1/2 times x minus 1.